Hello, hello everyone. Here we are with the another MATLAB program. It's the last one MATLAB program which I'm showing you here. So let's do this. So here we are going to do our bilinear transformation. So the bilinear transformation basically done on the digital filters and analog also, but here we are going to show on the digital filters only. So let's do this. First of all, I copied my program from one of the my Word document file. So let's complete it. So here we are. First we have taken over the sample frequency, then the cutoff frequency value, then the bandwidth value. After that we have defined our angular frequency value, and the angular frequency value is basically it should be using WC, WS and the minus of them. So the later on we will set our the maximum amplitude value and our minimum amplitude value. After that it's a sorry, it can be represented for the analog and the digital filter both bilinear transformation, but here basically we are had represented for the analog filter. Sorry for that, for the before telling, and then after that we will define our uh, polynomial form. For that we will use CIEL, and the n variable is used on with this. After solving all this mathematical equation, we'll go inside that, and then we will set our 0 and the poles value. For that we will use our Butterworth low pass filter, so we will use ButApp, and then we will use for the transfer function ZP2TF, and then later on for the band stop transfer function we will use LP2BS program, and then we will use for plotting this. It's a board diagram. So for that we will use figure and board, and then here it's a bilinear transformation, so we use bilinear for telling it's a bilinear transformation or on what it's done. Okay, so now let's run it. It's already run. I've done it in the video, as you can see. So here we have our board plot diagram. In the board plot diagram, it's showing the magnitude, phase angle, both of them. Okay, so you can clearly see it's showing our magnitude for mostly filter, but not for a particular band. And our both values you can't say that the similar to the other one IIR filter, because it's a board plot, and that's one is a frequency response representation directly, so there is a difference in between them. So that's all. This figure is completed. We have it our output waveform after using this bilinear transform. So let's so it's not figure is not clear little bit, but once I already shown you the clear figure diagram. So now there is a few issues here. It's a showing this values also. This is the values, or it's showing is of the previous output, not from this one, because in this one there is a we didn't write the command for displaying output in the command window. We just write for the plotting only, and did the mathematical representation, and for representing how it need to represent all that only done in it.